So here we are on our final lesson of Unit 9, and technically the final lesson of our Calculus and Vectors course. And we get to end with a bang by exploring the intersection of three planes. So lots of exciting visualization to do here and lots of exciting math to do. So we'll get right to it. So here I have an example of three different planes. If you look closely, the first one is up here, the second one is here, and the third one is here. Let's reveal each of them on their own. So we have this plane here, which is in blue, second plane above it, which seems to be not quite touching it, and a third one below it, which seems to also not be touching it. And if I look around, you will see that these are indeed three separate yet parallel planes. Okay, so our first scenario, our first option when you're investigating the intersection of three planes is that they don't intersect. Okay, there you can see them clearly not intersecting. Okay, so this version is called type 1. There are 4 different types, and in fact, in some of the types, there are some subtypes. So the first type is type 1, that we will call the intersection is when we have 3 parallel and distinct planes, and therefore there is no intersection of, or common intersection of the 3 planes. Now, if we look closely at these equations, you will see that there is some similarities. So remember, the normal is the defining characteristics of the plane. So if we look at the normal, which is the coefficients of all the letters, or all the numbers, letters and numbers, you'll see the normal for this one is -1, 1, 3, and so is this one, -1, 1, and 3. But they have a different constant here, which means their position on the graph must be different. That's what separates them, even though the normals are the same. Okay, and if we imagine the normal sticking out of this guy, and the normal sticking out of this guy, and the normal sticking out of that guy, all of those normals would be scalar multiples of each other. They're the same normals, but just different planes. And if you check the third one here, 2, -2, and -6, that is a scalar multiple of these normals. If you take the normal here and multiply by -2, you will get the normals for this. All right, we'll look further at that. But this is the first visualization that I want you to think about. The type 1 being the intersection of 3 planes, being they are 3 parallel and distinct planes, and therefore there is no intersection. Let's see what else is possible. All right, so again, here we have 3 normals, and let's do a little prediction here. So if you look at the normals, or 3 planes here, you see the 3 normals here, -1, 1, 3, -1, 1, 3. I anticipate that these two are parallel, and I also anticipate they'll be distinct because of this different value at the end. Let's check. So there's a blue one, and yes, there indeed is the third one. Let's predict if the third, or if the second plane is different, and yeah, indeed it does look different, so that's good. Okay, all right, so now I wonder about the third one. Let's check their normal. 1, -3, 5, so that is not a scalar multiple of this, which I'm now going to predict is not parallel, and indeed it's not. Okay, and so this is a possibility. This is called a type 2 possibility, where 2 of the planes are parallel and distinct, and the third one cuts through them and is not the same. Okay, so if we're investigating the intersection of 3 planes, while there is an intersection between the gray and pink and the gray and blue, there is no common intersection between all 3 of them. There's no spot where all 3 of them intersect. And so as a result, the conclusion for this type is also that there is no intersection of these 3 planes, no common intersection of these 3 planes. Okay, so both type 1 and type 2 you'll actually be hoping for, because the math is relatively easy. We just compare to see if they're scalar, or if their normals are scalar multiples, which would then make the planes parallel. And if we have either of these situations, then we know the conclusion is there's no intersection and you would be done. So there's type 1 and type 2. Wonder what type 3 is going to look like. All right, so here I have another one. If we do again some predictions, you'll see that 3, the normal for this is 3, -2, 1. This one is 4, -1, 1. And this one is 9, -1, and 2. And so there doesn't seem to be any connection between these 3. They're not parallel. So let's go and look at them. There's the first one. There's the second one. So definitely not parallel. In fact, they intersect there. And a third one. Oh, so the third one is also not parallel and it intersects a little bit differently. So if we look at this, we can kind of see there's a pretty good representation there, okay, of all different ways. So these are intersecting, but again, if we think about a common intersection, there doesn't appear to be a common intersection. Okay, but there is something, some characteristic about this that I will demonstrate in a moment that do make them kind of similar, but not the same. Okay, and if I kind of flick them around, you might start to see something that is the same about these. Okay, we can kind of start to see some similarities there. Now, if I show you a picture of this, you might have a better idea of what is the same about these. So let's actually go and look at our notes for a second. There's type 1. There's type 2. Oh, actually, before I reveal the next one, I don't want to give away something. So there is something the same there, and we're going to come back to that in a moment. All right, let's go back to our visual. There is something similar, but we're going to get to that in a second. Okay, but safe to say there is no spot where all three of them intersect. Okay, I don't know if you can see that. There's no spot where all three of them, they do intersect with each other in different ways, but no spot where there is a common intersection. All right, so this is type 3, and you see I've got TRI. The reason I've called it TRI is that it creates this triangle. You can kind of see this triangle of them being webbed together. Okay, but there's no common intersection. All right, so let's actually look ahead at another situation. I'm going to give you a hint that this is also type 3, but looks a little bit different. It's got BK. So let's actually look at it. So again, these are not parallel, but look at how these intersect. These ones do intersect at a common spot. And if you see that they all slice through the same line, okay, so these do intersect at a common spot and do have something in common. Okay, so why are they both type 3 even though they look very different? And the first type 3 has no intersection, and the second type 3 has an intersection at a line. So that's where I'm going to go back to our pictures here. So there's type 1, no intersection. Type 2, no common intersection. Type 3 are these two. And if you see here, you can see that maybe that similarity that I had shown you pops out. That similarity is that all of these are kind of resting on a desk. Now, if you imagine this shape resting on a desk and this shape resting on a desk, they all kind of rest on their desk. And their normals have something in common, which I'm going to come back to in a moment. Okay, so that's what makes these characteristics same, is something about the normals. However, this, if they're arranged this way, there's no common intersection. If they're arranged this way, there is. So the BK in my thing before stands for a book, because you can imagine that this is a book with like the seam here and all the pages sticking out. So they do have a common intersection, even though the pages themselves don't touch. They do touch right here. Okay, and then this one doesn't.
All right, we're going to investigate the intersection of three planes, type 3. Okay, and so I'm using these three binders to represent the three planes, and right now they're all resting on this patio table. But right now it's set up kind of like the book version. So you see how this would be like the stage of the book, and all of these are the pages coming out from it. You could also have it arranged like this, and imagine there's the spine of the book and all the pages coming out, but they both do the same thing. In this case, they all intersect at this line, this common line right there. Okay. The other option for type 3 is that they're arranged like this. So you've got coming like this and like this and like this. Okay, so this is the triangle way. On GeoGebra, you saw that these planes went further in other directions, so it kind of also looks like a star. But regardless, you can kind of see how there's no common intersection between all of these. These intersect here and here and here, but there's no one spot where all three planes intersect.
Let's go back to our GeoGebra. So there is the type 3 book. versus the type 3 triangle. Sometimes this is called the type 3 star because it kind of makes like a star. So those are both type 3. All right, our last example is type 4. Okay, so no real hint there, but let's look at those. So again, if you predicted with the normals, you'll see that there are no scalar multiples, so all three of these are not parallel. So there's a first one that's kind of facing right at us. Here's a second one, and these two seem to intersect at this line, and in fact I can sort of highlight that they do intersect at this line. And I wonder what the third one does. Oh, it comes at a different angle and intersects someplace else. So you can see here that these all intersect. They actually is one spot where they all intersect, and they intersect at a point. So if I click here, you will see that point of intersection is the spot where all three of them do come together and intersect at a point. Okay, so I'll just click off this to make that pink one. There we go. So you see how all of these planes do intersect at a single point. So they look very different than the other ones we have. They're not parallel, and they're not situated the same way like they are in type 3, and they intersect at this point. Let's go back to our notes here. You can see this. This is also another way to visualize this, that they intersect at a point. Now, we're going to need to talk about the difference between type 3 and type 4 so that we can know if we have this type of intersection or this type of intersection. Now, before we do that, I'm going to summarize this bits of information. So the intersection of three planes, the first type, type 1, is this. Okay, so you saw that visual representation. If you check, their normals would all be coming out of the page. So if I drew a normal for this guy, or come up like this guy would also have a normal like that, and this guy would also have a normal like that. And it doesn't matter how long they are. Can you agree that all of these normals would be pointing in the same direction? So the normals are said to be collinear. They all lie in the same line. Okay, so you'll be able to tell if they're scalar multiples of each other, they are all collinear, and which means these planes are parallel. And you'll have to do an investigation to be able to figure out if they're distinct. There is a chance that maybe all of them are actually the same plane, but if they're distinct, then they would have no intersection. Let's look at type 2s. So two of the planes are parallel, so that means two of the normals, let's draw that normal and maybe a normal over here, would be scalar multiples of each other, parallel. Two of them would be collinear. Okay, but this third one, the normal for the third one would be coming out at a very different thing, probably coming out something like this. So this third one is not collinear or not a scalar multiple of the other ones. And as long as these two are distinct, and we'll have to demonstrate that they are distinct, separate from each other, then there is no common intersection. If it turns out that we find out that these two parallel ones end up being the same plane, then there is intersection. It's the line. But really, if these end up being the same plane, then you don't actually have three planes. These two end up being the same one, so you have one plane and a second plane that's non-parallel. And it would be like yesterday's work. Okay, so we will need to demonstrate that two of them are parallel and distinct, and the third one is not parallel. We would have type 2, and in type 2 there is no common intersection. All right, now let's look at this. Here, this is our type 3s, and we said that there is something in common. It says the planes are not parallel, but the normals are all coplanar.
Now, both of these, even though they have different conclusions, no intersection or a common intersection like a line, they both have something in common, and that is how their normals behave. So what I'm going to do, let's actually position it like the book. So I've got this, and this. Actually, we'll go here. So let's look at the normals for each of these. So the normal of this guy is perpendicular to the plane. So you see it would look like that, and it would come over and look like that. The normal for the blue guy would again be perpendicular to the plane, so it would look like this. Could be anywhere, but it's perpendicular to the plane. It's not like this because that's not perpendicular. This one is. And then the third normal would be, of course, perpendicular to the plane and look something like that. The one characteristic about all three of these normals is that they all are coplanar, which means if I just rested the normals down, so I'm going to take this normal and put it right down there, and this normal, which is also perpendicular, put it right there, and even this normal, and I'm going to put it right there, and then take away these planes, you will see that all of those normals exist on the desk or on the table. So they all are in the same plane. None of these are different. So if I put them back, here's the red one, here's the blue one, and here's the yellow one. Okay, you can see that they are all coplanar. They all exist in the same plane. Okay, if I change one of them so it's not sitting on the desk, if I change this one, for example, and tilt it up, that would mean the plane would look like this, and it no longer is a type 3. Okay, this is a different situation. Okay, so that's the one characteristic about them. And even if I had the triangle situation, so for example, if I had the triangle situation and I had this coplanar, or that normal, excuse me, that normal way over here and that normal, and remove them, you can see that all of those exist in the same plane. How are we going to do this mathematically to prove that they all exist in the same plane? Well, if you've got three normals, and I've just brought them together, the way we're going to do this is take two of the normals, let's say the yellow one and the blue one here, take those two of those and find the cross product. The cross product of these two will result, remember right-hand rule, in a vector coming out of the page. So this is going to be our result of the cross product. We're going to compare the cross product, this new vector, with the third vector, the third normal. So we took the blue one and the yellow one, got a cross product, which is this black one. Now we're going to compare this black one with the white one and see if these are perpendicular. If they are perpendicular, this third one must also be on the plane because it would be perpendicular to this normal. If the third one is not perpendicular, so for example like this, you can see that it is not it's not perpendicular and it's not coplanar. It's not lying on the table. Okay, so our goal then to see if it's coplanar, you take the cross product of two, it doesn't matter which two, so I'll do the cross product of these two is going to produce some vector there. Compare it to the third one. If it's perpendicular, the third one must also be on the desk. If it's not, then it's not coplanar. If they are coplanar, then you have type 3. If you have one of them that's not, then you've got type 4.
Okay, so hopefully that you've had that visualization of what coplanar is and how to figure it out, and that will allow you to figure out that it is type 3. And then you're going to go off and assume that there's an intersection and find out later if there isn't, and then you'll be able to solve that one. All right, and then moving to this fourth example, or type 4, you'll see that the normals are not coplanar. So two of the normals might be parallel to the desk, but this third one is opposite to the desk. And so it would not be coplanar. So for example, this guy here might have a normal coming out like that, which would be parallel to the desk. This guy might have a normal coming out like this, which would be parallel to the desk, or at least lie in the desk. But the third one is very different, okay, and not be lying on the desk, and therefore this is not coplanar. So if you know that none of them are parallel and the normals are not coplanar, you know that there will be a single intersection point, and you can go off and work at trying to find that single point right there as the one intersection. All right, so that's the setup for this. We'll now go on and do a bunch of examples where you can see the math that would support finding the intersection of these three planes.